Hi everyone, good morning. Again, we are going to start session for the Security Plus and we are discussing about 701. Here what we are learning about Security Plus program. It's a course which is basically required as a security. If you want to become a security professional, you need to understand all these. So what is the most important motto is there? What the most dangerous attack, you must know about that. So most of the part of the Security Plus we have done successfully, and this is what we are going to start day 11 session. In this you will learn about some networking devices and security devices which plays a very important role in security. When you are in a network, when you are using your machine, your laptop, your tablet, your mobile phone. So in this we have the multiple features are there by which we can secure our machine or the devices, whatever the device we are using. So why we are securing, why the security is need? So your machine or the device cannot be compromised with anyone. Okay, now just I am going to share my screen to you so that we can continue today's session. You will understand it. So here let me share the full screen to you. So first of all, in this session SY0701 CompSec Security Plus program, in this firstly we will discuss about networking devices. So I think the most of the people who has idea about network plus, they know about the networking devices. So the devices which we use in a network environment, for what? To input, to collect the aggregate and transmit the data from sensors to processing system. These are the networking devices by which we are connecting devices to each other. Like for example, routers, switches. Okay, these are the devices which is used to manage traffic within networks. Okay, these are the devices which are responsible for directing data to correct destination. So we are going to discuss step by step about all the devices. The most of the devices we are going to discuss in this session, these are the network security devices. If we talk about, if the devices are communicating to each other, there is a very important role of the sensor. What is the meaning of the sensor? So you may be you have a remote, okay, by which you control the channels of your TV. Some temperature sensors are also we use for the like smart thermistor, which detects the room temperature, body temperature. Okay, these are basically used to, if you are using a room temperature sensor, by which you can adjust the heating and the cooling automatically. The AC, you have these type of sensors. If we talk about collector, that devices which work like a collector, these are basically what? These are the gateway in a smart home system. Okay, these collects the data from various sensors. If there is some motion is there, if there is some any light is there, and if they find, if the sensor sense these type of activities, these sends it to the central home automation control for processing an action regarding it. Okay, some cameras are there now, the detection, if there is any movement, then the camera will start recording, otherwise it will not record anything. So these type of, you can say, these are the example of collectors. Now just we will discuss about the type of network monitoring devices. What are the network monitoring devices? Here we have some example of these devices. Like first of all, if we talk about, if we categorize these, the one is active, second is passive, inline, and network tape. Active network monitoring devices, basically these are the devices which interacts with the network by injecting traffic or alerting system behavior as a part of its function, like a network testing tool. If you are using any, that sends a packet to the measures, if there is a network, to measure the performance of the network and health by the observing response. So these are what the active, like if you are using internet connection and you want to measure the speed of your network. So if you have any type of the device which by which you can monitor, you can manage, you can check what is the network speed is now currently, you can use. So the most of the time we use on internet to check the speed of the network also. Now the next is what the passive network monitoring devices. So these are the devices which monitor network traffic without alerting, and these are not basically not doing any alter in it, okay, or without interacting with the data. So what you can say, a network device monitoring tool, this is what passive tools that capture and analyze the traffic for audit. The purpose is what, without injecting packets or modifying traffic flow, it works. So next we are moving some type of the inline network monitoring devices. Inline monitoring devices what? So the monitoring devices which are basically currently monitor every activity which is going through the network. Its example is what? A firewall. A firewall configured to inspect and filter all traffic entering a network segment, or blocking or permitting data packets based on the services, whatever the permissions you have applied on it. Now we are coming to the next, which is what the network tape. This is also a network monitoring device. You can say a device is insert at a specific point in the network to monitor and copy traffic without disturbing the flow of the network. A network tape installed between two switches. If there are two switches, then we install this network tape between these two switches to duplicate the traffic to a monitoring devices for security analysis without offering network operations. So here we have four type of network monitoring devices. One is active, passive, inline, and network tape. Here in this we have some decision states are there in these monitors. So first is what the true positive. True positive, this is what, it's a network decision state where it gives the information what the correctly identifying an event of or the condition as a present. Like for example, a malware detection system correctly identify the flag a malicious file. This is what true and positive. Currently anything if you find, this is what comes under the decision state, true positive. The next is what the false positive, incorrectly identifying an event or conditions as present what it is not. An antivirus software flags a safe file as a dangerous file. You have a safe file, but the antivirus is showing this is what the dangerous file. This is what the false positive. Okay, this is what it's creating, it's leading to unnecessary action or concern, which is not basically virus, and it is indicating or showing you like it's a dangerous file. True negative, now this is come, the correctly identify that an event or the condition is not present. It is just like that a network monitoring system correctly determines that a network packets is not threat and allow it to pass without alerting. Means this is the threat. If you are having a threat, but it is not considering this threat as a threat, and it is allowing passing to the network without any altering. False negative is what? False negative is what? It is failing to identify an event or condition when it is actually present. A security system fails to detect an actual institutions what is going to be happen, and it's allowing unauthorized access without triggering alarm. It is not showing any alarm and it will allow to the outsiders to enter inside of the network. But true negative is what? It will allow whenever the entry will be in the network of any unauthorized access, it will generate alert for that. So here we have some related to decision states when we are using any security or network security device. In this we have the four decision state: true positive, false positive, true negative, false negative. Device failure mode. So here if we are using devices in the network, there is possibility of the failure. Basically we are working on an electronic device and there is a most possibilities there the devices can be fail. So what are the conditions here and what are the mode when the devices are fail? Now the first is what? Fail open mode and fail close mode. Fail open mode is what? The failure mode where a system default to allowing the traffic through when it is malfunctions or shuts down. For example, if a firewall experiencing a malfunction and defaults to allow all incoming and outgoing traffic, potentially exposing the network to the threats. This is what the fail open. Fail close is what? A failure mode where a system default to the blocking all traffic when it malfunction or shut down. An access control system fails due to a power outage and locks all doors, preventing entry of exit until the system is restored. So the failure of the one device which can close everything where the work will stop completely. But somewhere where the devices fail in fail open, the network will be work on the default mode. There will not have any obstruction of the policies which you have applied. So this will start working on default mode. The network is open, which is we called fail open. After failure of the device, the network will work on a default environment. There will not be any restriction which is applied by the device. But here in the second fail closed, if the device will get down, shut down, so it will stop everything. It will stop everything, preventing entering and everything. You have to restore the device. You have to reinstall the device, then it will start working. So here we have two modes are there. The one mode is what? The fail open, and the other one is fail closed. Network access control is what? This is what? NAC. NAC is a network security solution that basically where we have the policies are there, or you can say this is what the policy based access control to the network resources. It is used to evaluating the authentication or authenticating devices and users before granting access. Okay, so if you want to if you want to grant the access to the users to access any specific device or data, then you can manage it from the network access control. For example, when an employee connects their laptop to the corporate network, or you are an employee, if when you go to your office and you connect your machine or laptop to the corporate network access control system checks if the device complies with the security policies before allowing access to the sensitive resources. So access is restricted if the device does not comply, and remediation steps may be provided. Now just we are moving to the next network access control, where we use and the what devices where we use the network access control. First is what very important, you find this in your machine, in your laptop, in your tablet, and these are basically different categories of firewalls are there. We call this is firewall, a network security system that monitors and controls incoming and outgoing network traffic based on the predetermined security rules. If you have predetermined security rules, like if you have applied the rules, if there is any uh, IP address is there which is started with 2000 so it is not allowed to enter in the network. So this is what the predetermined security rule. If you set any rule, then it will work on it. Like a firewall blocks all incoming connections from unknown external addresses to protect an internal corporate network. Like you know about that your network is working on C class IP address. So if anyone is there who is sitting outside, if they want to enter in your network, they want to work anything in your network, they want to join your network, they should have the C class range of IP address. If they are trying from any other class of IP address, they will not be able to access, or you can set the range. So the whatever the rule you define inside of the firewall, it will start working according to it. This is what a network firewall. In this we have also the network access control, by which we can control the traffic, what the traffic is incoming in the network and what the traffic is going outside of the network. Next is what IDS and IPS. These are basically the devices which are used to monitor the network. IDS, intrusion detection system, and IPS, intrusion prevention system. So what these are two? These are two devices. The one is what it gives the report after detection. What is going on? It detects everything. So IDS monitors the network traffic for suspicious activities and send alerts, while the IPS actively block the prevents those threats. So what the IDS do? If anything is coming which is not, you know, familiar to your network, which is not authorized, which is not which is dangerous, I think, if if it find anything which is not relevant to your network, then if it is finding some thread is coming to your network, it will not stop it, it will allow it, and it will generate a alert related to this thread. This thread is coming to the network, and an administrator will finally check what the thread is coming from, where it is coming, who is trying everything, they can monitor at their end. The second part, which if we talk about IPS will not take the time to do the action. Like if it find the thread is there, then it will block it, it will prevent any type of threat which is coming to the network. And for example, an IPS detects an attempt SQL injection attack and immediately block the offending IP addresses from accessing the web server. But IDS will not do this. Okay, it will generate an alert, and then this will pass you message what is your decision you can take. Next is what the jump server. So we have completed firewall, IDS, IPS. Now we are coming to the jump server. This is what the secure control entry point for the administrator to connect to other devices within a private network or any zone of the network. For example, IT staff use a jump server to securely access and manage servers located in the data center. So one server is there. If they want to work, okay, so they can jump to the another server to work with the same. So here we have the multiple access control systems are there, by which we can control the network traffic. Here the more access control options we have. One is what the proxy server, NAC, DLP. So we will discuss about that also. What is the proxy server? Okay, like proxy server is intermediate server between a user device and the internet, which provides varying levels of the functionality, security and privacy. Like proxy server is its work like a cache server, or you can say the cache web pages, and provide the web filtering services, blocking access to the certain websites as defined by the corporate policies. So in through the web proxy server that will increase the performance of the network, we can share the web pages or the websites with the users of our network. Also, we can protect the website which is not required for our organization. So this is what here also we can use. This is for the network access control. NAC is what? Network access control. Ensure that the only complaint and authorized devices are allowed to access to communicate on the network. This is called network access control. Network access control is used in a system, or it's a network access control system defines, it gives the it gives the restriction, it's provide the restriction to unauthorized users by if you are creating any policy under of it. So you can say a network system defines the network access to a device that has not installed the last security patches. This is what network access control. DLP is what? It's nothing. It's a set of tools and procedures used to ensure that the sensitive or the critical information is not lost or not misused or not accessed by the unauthorized users. For example, a DLP system detects any blocks, an email containing the credit card information from being sent outside the corporate network to the other other branches. It will prevent it. Now just we are moving to the next. Here we it is very important to understand the differences between IDS and IPS. So firstly, here in the in the left hand side we have the features like functionality, operation, deployment, response, complexity, impact on the network. And other end we have the at the table. In this we have mentioned about IDS, intrusion detection system, and IPS, intrusion prevention system. If we talk about the first, the functionality, so IDS is basically used to monitor the network traffic, and it's generate alert on the potential threats. If there is any threat, it will generate alert only. It will not do anything more than that. It will generate alert and it will send a message to the administrator. Uh, there is a threat. Some unknown activities are going on. Now the next is what if we talk about the IPS, intrusion prevention system. It's monitor the traffic, and also if it is finding any threat, it's actively blocks it. It actively block that, and it prevents the identified threats. If it is identifying any threat, it's blocked. Now if we talk about operation, the operation of IDS is passive, observe traffic and generate alert only. IPS is basically the operation of IPS is active. It take action to block the malicious traffic. If is there any malicious traffic, then it will block it. If we talk about deployment, so the deployment outside of the direct network flow, monitoring and copies of the traffic it generate. But IPS plays the inline to directly control all the network traffic. If we talk about the response in IDS, the alerts administrator about potential security incidents, but IPS automatically respond to the threat by blocking harmful traffic. It will not wait for the administrator action. It will automatically respond to the threats. Complexity, if we talk about IDS, this is less complex, primarily focused on the detection only what is going on. It is used like a CCTV camera by which you can check the people how they are coming and going. You cannot catch anyone. Okay. So if we talk about IPX, this is what the more complex due to the need for the real-time threat mitigation. Impact on the network. If we talk about IDS, generally has no direct impact on the network traffic. But if we talk about IPS, it is basically check everything. If it is finding any malicious uh, traffic, then it will stop it. It will basically prevent it to enter inside of the network. And it also can introduce the latency as it is as it analyzes and takes action on the network traffic. IDS decision engine is there. So in IDS we have the four decisions. So first is what the pattern matching, rule based, behavior based, and heuristic. If we talk about the pattern matching, this is what it's basically compare observed activities or the data against the predefined pattern to the identify matches. For example, so how the antivirus work basically, it's check, it has a directory of the list of the viruses. It's check if anything is any file is matching with that, it will detect it. Okay, so the antivirus software detects the malware by matching file signatures against a database of known threats inside we have of the antivirus. It's checked according to the rule. Now the next is for rule based. Use a predefined rule to make the decision. If the condition of a rule are met, the corresponding action is taken. Like firewall, a firewall block access to a website if it is URL matches any on a list of the block site. This is what it can be done with the help of IDS decision engine. If there is you have mentioned if any traffic is coming from outside which is related to this URL, it should not be allowed. So what it will do, it will blocked site, list of the blocked site. Now the behavior based IDS, what the IDS do, it's check the behavior, analyze the behavior of the system or user to detect the malicious or the any indication which is just like a threat. If it is finding any threat which is any data or the traffic is coming to the network and it's indicating a threat, this is what it's check the behavior of any user or any system which is acting or which is working like a threat. And like for example, an intrusion detection system flag unusual activities. If an unusual activities are there, like for example, the person is basically is the employee of the organization. He basically comes in morning at 10 and he out it at the evening time. So if this type of user is basically try to log in night time in the network, in midnight, in early morning, so it is what the behavior is changing. Why this user is basically entering inside or login into the server. So this is not a time of the user to work on it, and he is using these servers randomly. Okay, so this is what the behavior is changing here. So IDS check all the activities which are going on the network. Now just we are moving with the heuristic. Heuristic is what here. So heuristic is what here. Let me. Yes. If it is working, basically it's totally based on experience. Some experience based techniques are there. The ideas learned from the last experience, and it's used to compare these new scenarios with this. Okay, so the last experience is what the most of the users, they basically use the software. They have the permission. Out of 1000, only 10 people they use a program, a software. This is what the ideas have a experience about that. The only these two users come to this. Okay, if there's the on the software automatically, the if it is finding like 20 users are entering on this software, 25, and the time is not basically the right time when they are accessing this software, so it is indicating what there is something wrong. So when the whatever the activities are running in the network, it's generate an algorithm for it. It's a pattern, like this user will come on this time, this user will come on this time, this user will come on this time, this time the traffic load will be the like this type of the traffic load. Okay, for example, email filtering software uses the heuristic analysis to identify the spam. Like for any spam is coming to the network or the server, so once it can enter, the second time whenever it will come to the network, it can easily identify. It can easily learn from the new pattern. Okay, and if it is finding new things, it will add into the experience, so that in the future, if any type of this type of data will come to the network, it can stop or it can detect, and after detecting it, it can generate alert for it. So these are what the IDS decision engine. Now we need to understand the type of proxy server. Here you can see these are basically three categories of that: forward proxy server, transparent proxy server, and reverse proxy server. Forward proxy servers are basically these are the proxy server which we set between client and device of the internet. Like I have a router which is connected to the server by which I am controlling the internet services for my clients. So any server, whenever they want to access internet, it has to pass through the server which is connected in my network as a proxy server. So it is the server which basically, or the proxy server, it's basically sits between the client devices and the internet, directing outgoing request from the client to the server. For example, in a corporate network, forward proxy filters internet access and provides a changing or provide the caching or any the activities which the users there need continuously. Okay, they want to access a website continue on continuous basis, so it will provide it from the cache only, and it's improving the browsing speed for the internet users. So what is the meaning of that? Like for example, if you want to access any website now, so it will your machine as a client machine will send a request to the server. Server will forward it to the DNS, and just it will go to the server which you want to access, and your server, your proxy server will get reply, and then you will be able to access it. The next time once again you will search the same server, your server will not send request to the main server. It will share you the reply from the cache of this server. So it is basically what improving the browsing speed of the internet users. This is called forward proxy server. Next is what the transparent the servers are basically intercepts and redirect web traffic without any configuration required on the user's device. So users are generally unaware of its presence. IPS uses a transparent proxies for caching connections or the caching web content and logging internet using without the end users activity or end users active environment. If we talk about reverse proxy server, so it is basically resides at the edge of the network, directing client requests to the appropriate backend server and delivering server response back to the client. It is like a reverse proxy server handles the traffic to a popular website, providing a load balancing to ensure the efficiency and reliability to the backend servers. So these type of servers are there related to the proxy. We call these are proxy servers. Now we will go with a data state. So we need to understand what are the data state for the security. Data at reset, data in use, data in motion. These are three state of the data, whatever you have. So a data at a reset. So this is what the data that is stored on a physical or a digital storage in your hard drive. Okay, on like pen drive, physical storage devices or digital storage devices, and not actively being used to proceed. For example, encrypted customer data stored in a database that is not currently being accessed or modified. This is what rest data. This is what rest data, which is not in use. So if you want to do anything with this, you need to activate, you need to use this data. This is what the rest data. Next is what data in use. Data in use, data being actively processed and used by application users of the system, like employee accessing an updated customer record in CRM system during the normal operation. So any program which is in use, any data which is in use, this is called the data in use. The next is what data in motion. Data is motion is what? There is a difference in data in use and data in motion. Data in motion is actively moving from one location to another location, such as across the internet or through the private network. Sensitive emails being sent over the SSL TLS from a corporate email server to an employee's mobile devices. This is what the data in motion. And data in use is already I have given you idea about that. Reset is what you can say the rest data where just you have the data which is not in use. This is what uh, rest data. Now if we talk about firewall, what is the firewall? Already we have discussed about it, and already we have discussed about the type of firewall also. It's a network security device that monitors and control incoming and outgoing network traffic based on predetermined security rules. A firewall at a company's network, this gives the boundaries and block any incoming connection from unknown external IP address to protect internal resources. Deterrent control, here we have prevention control, here we have and detective control we have. In this we have three type of control. Deterrent control means intended to discourage violation of security policies. Prevention control is aimed to prevent security incidents before they occur while restricting uh, ingress and egress. Detective control means the design to detect and alert security policies violations. These is basically what the firewall. It is used for the protection. Here you can see the multiple firewalls are there. These can be of different companies. Fortinet is there. Fortinet is there. Palo Alto is there. Sonic Wall is there. There we have the multiple type of the firewalls are there. If we talk about here related to the security, uh, OSI layers are there, 7 layers are there: physical, data link, network, transport, session, presentation, and application. In this we have the one is the the common layer and topmost layer which works on firewall. So firewalls can inspect the data at the application layer and filtering content based on a specific protocols like HTTP and FTP. Presentation layer rarely interact with the directly by traditional firewalls, more common with the advanced firewall that performs the deep packet inspection. Session layer manage and control the connection between computers, not typically addressed by the basic firewall but by more sophisticated ones. Transport layer control the session based on port numbers and can manage TCP and UDP traffic. Network operate at the IP level, making decision based on IP address, and data link is some advanced firewall can filter the traffic at the MAC address level. Physical layer firewall do not operate at this layer as it handles the hardware transmission and receipt of the data over a physical medium. Now here we have a firewall type. It is very important to understand stateful packet filtering and stateless packet filtering. Stateful packet filtering is what? It's basically the firewall which monitors the state of the active connection and makes the decision about which network packet to allow through based on the context of the session. Like for example, a stateful firewall remembers that a user inside the network initiated a web session and allow the returned web traffic specifically for these sessions, ensuring that the only legitimate response to outbound requests are permitted. Stateless packet filtering is what? It's make decision about which packet is to allow through base. Okay, it's depending on the header of the individual packet without considering the state of the connection. A stateless firewall filter packet based on the predefined rules, such as allowing or blocking certain IP address or ports regardless of the connection state. This is what the difference in a stateful and stateless firewall type. Complex firewall also there, which is the new generation or the next generation firewall, NGFW we call this is. This type of the firewall that goes beyond the traditional firewall functions by incorporating additional features such as a application awareness and control, integrated intrusion prevention, and cloud delivered threat intelligence. Like these type of firewall can inspect the content of the traffic to block the sensitive data from leaking out of the network and prevent the malware from entering the network. It can also allow to block the traffic based on the application being used, not just the port or protocol. These type of the new generation or the next generation firewall. In this we have one more firewall, which is the complex firewall. We call this is a unified thread management, UTM, unified thread management firewall, a comprehensive security solution that combines the multiple security features and services within a single hardware or software platform. This include antivirus, anti-spyware, anti-spam, network firewall, and intrusion detection and prevention capabilities. It's a unified threat management, UTM. Nowadays, the most of the biggest companies are using these security device. A UTM device installed in a small business handles not only firewall duties but also prevent a virus spread, filter spam from mails, and detects and prevents the intrusions, all managed through a single interface or single device. Specialized firewalls. Specialized firewalls are what? The first is what the web application firewall, which is especially for web. A specific type of firewall that filters and monitors and block HTTP traffic to and from a web application to protect against malicious attempts to compromise the system or exfiltrate data. For example, WAF, which is called a web application firewall, is configured to protect an online store by blocking SQL injection attack and cross-site scripting SSS attempts that could steal user data. It can that could steal user data or deface the website. Next is what the virtual firewall, which is comes under the specialized firewall. Virtual firewalls are software-based firewall that operate in a virtualized environment as opposed to running on physical hardware. It can enforce the security policies on virtual machines, applications, and traffic within a virtualization or virtualized data centers. You can say a virtual firewall is a deployed within a cloud service provider's infrastructure to provide tenant isolation and protect each virtual network segment from unauthorized access and threat internal to the cloud. These are what the specialized firewall, web application firewall, we call this is WAF, and other one is virtual firewall. Firewall configuration and planning, here we have, so first is what the network topology map, second item we need the security policies, access control list, port needs, net requirement, firewall uh, details, failover setting, uh, logging and monitoring, update scheduling. So here we have the description also. If we talk about the configuration of the firewall planning, so firstly we need to need a topology detail and a map of the topology where what the devices are connected, the diagram of the network layout including all connections and the devices and interface. We also need to have the security policies, clearly defined rules about what the traffic is allowed or the block based on organizational security guidelines. We need to have idea about the specific rules that govern the flow of traffic to and from the network. Okay, network detailing allowed and define the services IP address and ports. That is what comes under the access control list. Port needs, we need to have idea about identification of the necessary ports for being operations that need to be open while others are blocked. So we need to have idea about the ports which are open and other ports should not be open, that these other ports should be blocked. Net requirement, this is what the network, we need to have idea about the network address translation settings, particularly if private IP address needs access to the internet. Also, we need to have idea about the failover setting configuration for backup mechanism to maintain the connectivity in case of the primary firewall fail. Logging and monitoring is what we need to have idea about. It is when we are configuring the firewall, setting up what the traffic and events should be logged and how monitoring will be conducting or connected to the ensure compliance and security. Updates regularly update are required for the firewall and software to protect against the new vulnerabilities. So this is you need to remember when you are going to configure firewall. So this is what the planning before you are configuring any firewall in the network. Firewall ACL is what the access control or the content of the firewall. ACL is what the secure IP address, destination, the source IP address you need to have, the destination IP address you need to have. Okay, protocol, source port you need to have, destination port, action, direction, priority, logging, validity. So these are what that comes under the ACL, access firewall access control list. So source address is the address from which the traffic is originated, and the destination address is IP address to which the traffic is directed. Protocol, the type of traffic. Here we have what the basically protocol is used for the communication, TCP, UDP, ICMP, and etc. Source port, the port number on the source device is basically working for TCP UDP protocols. Destination port, the port number on the destination device for TCP UDP protocols. Action specific, just it's basically what the inside of the ACL specify whether the traffic should be allowed, denied, or logged. Direction, the direction of traffic flow, that is also mentioned inside of ACL of the firewall, inbound and outbound. If you go to check in firewall, you find these details: inbound traffic and outbound traffic. Priority is order of importance relative to the other rules, and logging is whether to log the traffic that matches this rule for audit and monitoring purpose. Validity is the time or the date conditions under which the rule is active, when this rule will apply and this rule will not apply. This is what the validity of any rule which is defined inside of the firewall ACL. Secure protocol, if we talk about what is the secure protocol, the protocol designed to encrypt and secure data transmission across the network is called secure protocol, which is also enhancing the data integrity, confidentiality, and authentication. Like for example, HTTPS hypertext transfer protocol secure encrypt web traffic between browsers and web servers. So ensuring that the data like login credentials and credit card information are securely transmitted and protected from the any type of your tampering, any type of attack, any type of capturing of the data. Here we have these two protocol which are basically used as a secure protocol. One is what SSL, other one is TLS. SSL is the old one. In this SSL we have the vulnerabilities. Also nowadays we are moving to TLS. So here we have some details are there. One is what the aspect of the protocol, and second in this tab we have SSL secure socket layer and TLS transport layer security. If we talk about the history of these protocols, so SSL is developed by the Netscape in the mid of 90s for securing web communication. If we talk about the history of TLS, is what the successor of SSL, developed by the IETF with the first version released in 1999. So version, if we talk about the SSL, here we have SSL 1.0, SSL 2.0, SSL 3.0. But in TLS, we have TLS1, TLS2, TLS3, TLS 1.1, TLS 1.2, TLS 1.3. So here we have, this is what in 1.0, 1.1, 1.2, 1.3, but in SSL we have 1.0, 2.0, 3.0, like that. If we look at the security issues in this, the SSL, here we have the vulnerable to various attack and weakness leading to several security flaws. Okay, in this we have the vulnerabilities. But TLS is, the address vulnerabilities found in SSL, offering the stronger security mechanism inside of TLS, because this is the successor of SSL. So the now if you are using any security protocol, you need to move to TLS because it is more secure comparatively to SSL. Adoption, if we talk about, widely adopted initially, but the force, this is now, it is here because of the vulnerability of this protocol. So now it is faced a declining uses due to the security concern. Now, if we talk about the adoption of the TLS, is what become the standard for the secure communication on the internet, widely adopted. And here we have the next aspect of these protocol, what the reason for transmission, or where we use it. Okay, basically why we are using these. So if we talk about SSL vulnerabilities lead to its deprecation. TLS introduced the more robust security mechanism to address these issues. So TLS provide improved security features and a strong encryption algorithm. This is what SSL and TLS. In the next, I will tell you about how the TLS works and what is the handshake process. So we will learn more about this protocol. Till the next session, wait everyone, and bye. See you in the next session. Bye bye.